In this video, we're going to talk about finding solutions to quadratic equations, but not using the factoring method, using a guess and check method. So first of all, what do quadratic equations look like? Here's a few examples. We have x squared minus 6x plus 8, x squared plus x minus 12, and 2x squared minus 12x plus 16. Now, all of these are set equal to 0 because that's the form that we use when we're trying to find the solutions. Notice they all have x squared terms, they all have x terms, and they all have a constant. So these are just polynomials. We've seen these before, but there's a special process that you need to go through in order to find solutions. So what do quadratic equations look like when graphed? This isn't important for finding the solutions, but it does explain something. When you work with quadratic equation, there are often two solutions, and this is why these are the solutions for this quadratic equation, the numbers 2 and 6. Specifically, x is equal to 2 and x is equal to 6. And it's because this is a curved function and it crosses the x-axis twice that we get two solutions. But that's just background. What makes quadratic equations unusual? We can't figure out what x equals the normal way. There are often two solutions, as I just talked about. For example, there is a quadratic equation, x squared minus 6x plus 8. We set that equal to 0 for finding the solutions. And x equals 2 or x equals 4 are both solutions to this. What makes those solutions? Well, if we were to substitute x equals 2 into this equation, we will get 0 equals 0. We will also get 0 equals 0 if we substitute in x equals 4. Those are the only solutions. Those are the only two numbers that will make that 0 equals 0. So in this video, that's how I am going to solve these kind of problems. I am going to look for this situation in the answers. Here are the steps. Use the guess and check strategy, which simply means we're going to use the answers and figure out which one works. We're going to substitute in the values for x to see if it makes the equation true. But in order for a pair of values to be the answer, both numbers need to make the equation true. Just one of them is not enough. They need to both make the equation true if you're given two numbers. All right, a useful tip. The product of the two solutions will be the same as the constant in the quadratic equation, ignoring the sign. We're not worried about whether it's positive or negative. It's just the number that we're looking for. Let me make an example. We have this quadratic equation. Now, the product of the solutions is either going to be negative 12 or 12. It's going to involve the number 12. I know the solutions to this equation are 3 and negative 4. Just accept that. I'm not proving that that's the case right now, but just accept that that's true. And notice that the product of 3 and negative 4 is negative 12. So again, we're not worried about whether it's negative or positive. It's just, do we get a 12 when we multiply the solutions, the two solutions? And yes, we do. So that's sort of a way of confirming that you have an answer that makes sense. It can also help you eliminate some answers from the multiple choice. And I'm going to demonstrate that with this problem. I've got two types of problems that you might see here. Let's start with this one. In this kind of problem, we're asked which values are the solution to the following equation. X squared minus 6x plus 8 equals 0. So we're given two numbers in each one of these multiple choice answers. We need to make sure that both numbers work in order for it to be a correct answer. Now let's talk about that tip that I just gave you. I said that the product of the answers is going to be equal to the value of the constant without the sign. So let's look at what we have here. 1 times 8 is 8. So that looks like it might be a solution. 2 times 4 is 8. So these two are good candidates. 1 times 5, that doesn't give us 8, that gives us 5. So that cannot be a solution. And 6 times 7 would give us 42. That's not 8. So we can rule these two out because the product of those two numbers is not equal to the constant. Very helpful tip, because otherwise these can be a little time consuming because we have to substitute these numbers one at a time and see what it gives us on this left half. So let me do this for -1. -1 squared minus 6. And you're probably wondering, can I use my calculator for this? And the answer is absolutely. I'm going to do it by hand here, but you can go ahead right now and do that in your calculator. -1 squared, we want to make sure we put that -1 in a parentheses, is just 1. Minus 6 times -1, that's going to be plus 6. And then we have plus 8, and we can clearly see that this is not going to be equal to 0, it's equal to 15. So good news is if the first number doesn't work, we don't have to check the second number because it doesn't matter. They both need to work. So we have just eliminated option A, and we're really thinking it must be option B now. It's the only one left, but let's see how this works. 2 squared minus 6 times 2 plus 8. That's going to be 4 minus 8, not minus 8, minus 12. I was ahead of myself there. 4 minus 12 plus 8. And that indeed gives us 0. So 2 works. Let's check 4. 4 squared minus 6 times 4 plus 8. 4 squared is 16 minus 6 times 4 is 24 plus 8. And yes, that is also 0. B is our answer. But notice that it was super helpful to be able to exclude 2 of the answers, especially if those are the first answers. Let's look at problem 2. This is the other form of a quadratic equation problem. They give us the solutions. They tell us that these are the solutions to one of these equations. So we sort of have to do the same thing, but in this case, we're testing equations rather than testing solutions. So we're always going to start out with x equals -2. And then we are going to, if that works, we'll move to 5. But let's check our rule here. Based on our tip, our constant should be the number 2 times 5, or 10. Our constant should be 10. The first answer has a constant of 10. Once again, we're ignoring the sign. The second one has a constant of 10. C has a constant of 5, so that cannot be the answer. And D has a constant of 2, so we're going to rule that out as well. So once again, we're focused on A and B. Let's figure out which one works. -2 to the second power, -2 squared, minus 3 times -2. We're substituting in the same value of x. We're focused on -2 first. Don't make the mistake of putting -2 in the first one and 5 in the second one. We're only testing -2 right now. Okay, -2 squared is +4. -3 times -2 is +6. Minus 10. Sure enough, that equals 0. Now, it's often the case when the first one equals 0, the second one is also going to equal 0, but you should definitely test it. -3 times 5. Now, this time we're using 5 to replace both x's. -10. 5 squared, 25, minus 15, minus 10 equals 0. And again, you can do this all at once in your calculator and just test, does that equal 0? That's going to be quicker than what I did here, doing it manually. So take advantage of your calculator. You should always be able to use your calculator on a problem like this, I think. All right, that wraps up this video. Now it's time for you to do some practice on your own.